So to remove the coupling at the end of the shaft, you drive out this drift pin with a punch, and then you want to remove the shaft, but first you'll have to take off a little bit of the edge that's formed there from the wear. Just to make that smooth, and that pushes right through. So looking down in there, I don't see anything as far as an O-ring. There are a couple bushings in there, one in the top and one in the bottom. That's it. There's no O-ring in the bottom. There is a washer that goes here, so the shaft goes through that before the coupling gets put on. Now, this has 4 solid vanes on it, and if you look at the turbos, they've got one that has a window in it where the other 3 are solid. So that's how to tell if you've got a turbo distributor or throttle body. But it doesn't matter. I only need one of these to tell the engine when that cam is coming around the top dead center. So I can cut 3 of these off and hopefully make it work for my setup. And then on the top, like I said, this only has the one set of wires coming out of it, one connector, and I'll figure out a way to mount this on top so we can make it all work together. So looking at this pickup from the side, you can see how the vane goes in here, and there is a magnet present, so it's actually holding on the magnet. So that's the Hall effect sensor. And again, if you got a turbo, you're going to have 2 of these in there. So what I've done is to cut off 3 of the fins. I've only got 1 left, and that's the one I'll use for the cam sensor. My only concern would be on the balance. You know, I've taken some of the weight out of the rotating mass. You might get a little bit of out of balance, but these things are so light that I really don't think it's going to be an issue. I'm going to put a little bit of grease on the shaft, even though it didn't appear to have any before. I just figured I'll put some in now. Now, one thing I saw on this that kind of surprised me is the bottom of the distributor has 3 holes in it. I assume that's to let moisture out, but just kind of surprised me. Pretty snug fit. Now, one thing I just found while putting this back together is that the hole in this shaft is not center. In other words, if you put that on 180 degrees wrong, it will not work. So you've got to make sure that it's centered. You can look down through the hole and it's straight through. So I did not realize, but it is slightly out of line, that if you put that in the opposite way, it will not work. I've centered the pin, so it's the same gap on both sides. Spins nice and free. So now I can test it. One thing I wanted to verify is that if you wire these sensors backwards, in other words, the plus would go on the black, blue, and the minus would go on the orange, you'll end up burning out the sensor. So I just did that to the gray connector, and I burned out the sensor for it. But that didn't affect, I had the other sensor unplugged, so it's still fine. So I hooked that up normally, and I'm still getting my normal signals. But be sure you do not wire these backwards. The positive wire is going to go on the orange, and the negative wire is going to go on the black, blue. And then your signals are going to be your gray, black, or your tan, yellow, depending on which color connector you're using. So hopefully that saves somebody from ruining a good sensor. This one will still work because I don't need the gray sensor. I'm only using one of them, so I can use the black, and I'll be fine. I'll just cut those wires off for the gray. And something that I wanted to determine was if you have a Hall effect sensor from our distributors, how do you know if you get one, if it's any good before you try it? Usually you throw it in and you try to start the car and see if it works. So what I came up with was if you take the male connectors coming off the distributor, you got the black and the gray, the orientation is going to be the same. And the top left connector is going to be number 1, top right is number 2, and the bottom is number 3. So 1, 2, and 3 on both connectors. So what I did was I did an ohms check between each of the pins, and it makes a difference when you're using them that if you have the red or the black probe connected, your positive, negative. On resistance, normally it doesn't make a difference, but these meters work in a diode type fashion where you're actually putting a positive voltage on one side as opposed to the other. So you will get a difference sometimes if there's a diode involved or a transistor. So anyway, I did these in the orientation that you've got a black probe attached to one pin and the red probe attached to the other, and you can see I get 790 ohms of resistance, where if I attach the black probe to the number 2 pin and the red to the number 1, I get nothing. So it does make a difference on which direction you're attaching your probes if you've got a diode type meter. You can see that here, there's a diode symbol, and I'm on the 2K threshold. So that being said, what I found is on the connectors that are good, you get between 1 and 2, 1 being the black, you get 785 ohms, and that's the gray connector is the bad one. I get 790, so about the same. But the big difference comes in between pins 2 and 3. On the bad one, it's open. but on the good one, I'm getting 1950 ohms. So I would say the most important one to check is to put your black wire on pin number 2 and your red on number 3, and if you got 1950, 60 somewhere in there, you've got a good sensor, a good Hall effect sensor, where you can see on the other one I get nothing, so it's open circuit. So pins 2 to 3, regardless of which direction you put them. On the bad one you get an open circuit. Now keep in mind, when I did this pin 2 to 3 on the good one, I got 1950, but if I reverse the connectors, the probes, I get 815. So again, depending on the direction that you have your probes in, it's going to make a difference on what you're getting out of it for a resistance. But that being said, if you got nothing coming out, you definitely have a bad sensor. So the gray one is definitely bad. Hopefully that makes sense. I know I'm definitely going to use it if I ever need to check a Hall effect sensor on the distributor. That's a quick way to check it. Just go between pins 2 and 3 and see if you got an open, and if you do, you got a bad sensor, and you go across pins 1 and 2, you should have about 800 ohms of resistance, and that'll tell you got a good sensor. So what you're looking for, you've got 4 vanes inside the distributor, and as they come around, there's 2 sensors in here, front and back. This is the front, back. They'll pick up on the magnetic attraction of these vanes. The vanes aren't magnetic, but they're ferrous metal, so they'll make an attraction. So on the standard, normally aspirated, it's the front vane, the front sensor, that's going to trigger out of your black connector. You need to give it power and ground, and then you'll get a signal out of it. So right now I've got the rear sensor unplugged. I'm only using the front sensor, and I've got 3 of these vanes cut away. I took away the open window and 2 other ones, so I'm only using 1 vane as a trigger. The connection, this is how it looks in the wiring diagram, so you can see how things are connected. And again, I'm only using the black connector. And when you spin the distributor, you get nothing until the vane comes close to the magnetic sensor, and then it goes high. So whatever your input voltage is, that's what you're getting out. Now, as I said in an earlier video, you ideally want it to go to 0 volts, not to input voltage. So I'm working on trying to figure that part of it out. But at least now I've verified that there is a functioning Hall effect sensor. And I'm going to try to find it on the other one also. But at least I've got it functioning. Now keep in mind, I do have the 1 k ohm resistor in series, and that's between the positive input and the signal wire. Sometimes I can get blinders on when I'm trying to find a solution to an easy problem. I was talking about how I like to have the vane signal go from high voltage to 0 volts when it sees the vane. And what I'm actually seeing is when it's not seeing the vane, it's giving me 0 volts, but when the vane comes around, it goes high to 13. And I didn't want that to happen. I wanted to have the high to the low because that gives you a better confirmation that you're actually seeing a signal. And what it didn't dawn on me is that, well, it's now high because it's seeing the vein, but when the vein goes away, it goes to zero. So I have my high to low, and it's going to be almost a full revolution before it goes high. The vein will come around, and it'll go high, but the controller will ignore that high and only act when it goes back to zero. So I've got what I want. It just took me a while to figure out that I had it. So hopefully that clarifies some logic for you. That'll do it for this week's video.